It's a dream of a satellite in order to calibrate the different spectrographs for every major observatory on ground.
What the Ancestor aims to achieve has never been accomplished before, so it's really a new kind of mission that will revolutionize how spectrographs observe our universe.
This satellite will be really the father of any kind of high precision measurement in the field of astronomy and astrophysics that is planned for the decades to come.
Today, in order to calibrate these spectrographs, so to allow them to be extremely precise, every spectrograph, every observatory has its own calibration source. With new Ancestor, we want to be perfect. We want to provide to all observatories in the world the same calibration source.
The problem is you are unable, as of today, to put the data of all these telescopes together. What new Ancestor will allow is to unify the data of all the instruments because it's providing what we call a universal calibration light from space, illuminating all the ground telescopes.
To have one source of calibration for all spectrographs on Earth, it's like speaking the same language for everyone.
Spectrographs are watching not only at one color, not only at one frequency, but actually at a very broad band of frequencies, from the ultraviolet to the red or even to the infrared. So in order to calibrate a spectrograph, it's not sufficient to have one single laser line.
It has to be actually a laser frequency comb. So it has to cover multiple frequencies that can be used to calibrate the spectrographs.
There was a Nobel Prize in 2005 that was given for it, and it's the latest technology for the laser frequency combination.
Let's say it's like a ruler. At the output you have different lines that can be faint or strong and that are equally spaced in the frequency domain.
And that gives you a spectral grid that is just perfect for an instrument, because you have a reference that is always the same amplitude, and perfectly equally spaced.
Laser frequency combs are already used on Earth, but not yet in space. So bringing such a delicate device into space is a great challenge and has a lot of potential for new scientific discoveries.
The satellite must be on an orbit which is accessible from the north and from the south, and in addition it has to be a little bit desynchronized from the Earth's rotation, such that it will become visible by any observatory at least once per night.
The calibration light is received by the ground telescope, so the ground telescope has to find new Ancestor like it finds a star.
The Ancestor mission will be pointed to a spectrograph which can then observe this frequency and calibrate its own frequency measurements in an absolute and very accurate sense. This will allow then the comparison of various spectrographs on the whole world to get the best results.
In terms of accuracy, it's like if you are observing space with a single telescope, unifying all the areas, collecting areas that you have on the ground. So it will be the first project of this kind, allowing us to open the window toward a new accuracy measurement that was never achieved before.
We know a lot about our solar system, but then exoplanets are still a quite new topic. Humanity was probably always kind of asking the question, are we alone, or is there life somewhere else? How is the universe built up, and is our solar system special in a sense, or other worlds where the same things exist? By studying exoplanets, we can actually try to answer this question.
In order to be able to detect Earth equivalents, you need to go to smaller mass and to longer period, like 1 year. The hope is that with new Ancestor you can get there.
Remember, as Michel Mayor said, there is no plan B. There might be a planet B, but no plan B, so it will be difficult to go to planet B. But new Ancestor can help us with these accurate calibrations, so to refer to a frequency on the very long term to actually find an exoplanet which is as similar as possible to our Earth.
You can imagine that this is not a satellite making science for itself. It's a satellite which is providing services from space to the worldwide community.
We are calling all our colleagues around the world to join us in this fantastic project. We will have a fantastic calibrator from space that you will be able to access.